continuous. So Austin said discrete. Discrete. How would you say why? How would you say why?
What do you think?
Because you can only buy up to 4 tickets and you can't buy like half of a ticket.
Can't buy half a ticket. I'll agree with that. I'll live with that. Can't buy half a ticket.
Partial tickets.
Partial tickets. I like that. Well, that accounts for everything. Can't buy partial tickets.
That's right.
Good job. Hey, appreciate it. Here. Have some candy. Good work. So our domain is 1, 2, 3, 4. All right. Theoretically, can you buy? And this is always I kind of waffle back and forth on this. Theoretically, can you buy 0 tickets?
I was just going to throw that out there. I think yes, because that's an option.
It's an option,
But you're not going to buy it.
but you're not going to buy 0
Right.
tickets. So that's why I ordered.
Yeah.
So if you included 0, nobody would mark it wrong.
Yeah.
Let's go with that route.
Yeah.
Okay. And if you just start at 1, I understand because, like you said, why would you buy 0? Like, why would you include that? But probably 9 times out of 10, the booker throws in 0 tickets. Okay. I'm going to include it for this case here. If you don't,
I guess that's an option you have.
it is an option. So,
But yeah, it doesn't, you're not technically buying them.
right. So, you can't go negative. All right. Graph the function using its domain. It doesn't ask for the range here, does it? So we got to make a table of values. So what is our equation? Does it tell us up above? Yeah, y equals 15.95x because that is the cost of a ticket. So we're going to make a little table. So go ahead and do that. You should have plenty of room there. Over there on the right. Ton of room. So put y equals 15.95x. You'll need that calculator. We only are going to plot these points here. 0, 1, 2, 3, 4. So plug in 0 into your equation. If you buy 0 tickets, it better cost $0. So that's going to be 0. I can do that one. If you buy 1 ticket, what's going to be your cost? $15.95. All right, plug in 2, 3, and 4. Fill out your table. And then just wait. There's a pencil sharpener right behind Eddie in like the 3rd shelf back there. All right, Jeff, what do you got for 2?
For 2?
Yep, 2 tickets.
31.9.
31.9. Okay, what do you got for 3? What are you doing back there?
Not paying attention.
Come on, pay attention. Get to work here. Zach.
47.85.
47.85. And how about 4?
63.8.
63.8. And I put 80 because 80 cents. But if you put 0.8, that's fine. All right, to graph these, you got this unmarked graph. You're going to have to put in scaling. And there's some scales that are better than the others. Like if we're only going to 4, like don't crowd 1, 2, 3, 4. Don't just crowd everything here. Spread it out a little bit. Okay. Could it work? Yeah, but like make it look as easy to read as possible. So I'm going to go here. This still needs to be 0, but at least spread this out to 1, 2, 3, 4. At least every 2 marks. Okay. So you've got a little bit of room, and it's a little bit easier to see. Probably in this one you could go 3. I'm not sure. What about the y? Like, obviously, we can't go every 1 because we got to get all the way up to 63. So we want to use kind of as much of this as we can. So Mason,
We could do 5.
5, will that get us all the way up? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. That'll get me all the way up. You don't need to mark every 5 either. You can go 10. Okay, so skip 1 and go 10, 20, 30, 40, 50, and then that's 60. So now we got 0, 0. We put a dot. 1, 1595. You're going to have to estimate. That's fine. 1595 is about 16. Halfway in between 15, so it's going to be a little bit above there. 2, 3190, which is about 32. 3 and 4785. And then 4, 6380, which is going to be close to 65. Should I connect those? You should not connect those because you can only buy 1 ticket. You can only buy 2 tickets. You can only buy 3 tickets.
Because even though we don't connect them, if we with our estimates and stuff, shouldn't they? If you could, when they connect to be aligned, pretty much, right? They should be, but we're not going to connect them because it's discrete.
Maddie.
Would you be able to just list the X over on the side? I mean the Y over on the side, like as the points of the cost.
You mean like 1595?
Yeah.
You know what? If you have the table, then we should be able to figure that out from the table. I wouldn't list it over on the side. I would just keep my scale like that, and then we'd have that table. Okay, so you wouldn't have to go that extra route. All right, now this second one, I think I changed this one. Go flip it over on the back. I thought it was ambiguous. It was kind of hard to figure out. So you said an anteater consumes 30. Yeah, cross that out. And just here, we're going to use this one. Your friend.
Your friend from.
Who also knows Hans.
You want to pump? You
Your friend runs at a pace of 5 miles per hour. All right, so let's use that. So we'll change that, and then we're going to have to change. I think A will be just the wording change a little bit. So explain why the number of miles ran instead of anteaters or ants eaten. So you do that one. All right, something's a function. All right, first of all, let's think. Can you come up with an equation for this? Can you come up with an equation for this?
Would it be y equals 5x?
He says y equals 5x. Okay, so y would be the total number of miles, and x would be what? Number of hours. Okay. Something's a function if when you plug in one x value, you only get back one y value. So think about this. Is this a function? Or essentially, can you run, say, 2 hours and run 2 different amounts? Does that make any sense? No. Okay, so that's why this is a function. So for each input, there's one output. So this is a function for each input. And now, is the input hours or miles? Okay, is it hours or miles? Ava? It's hours. For each input, and I'm just going to put in parentheses there, hours. There is one, whoops, hey, go back to there is one output, and that is miles run. That defines a function. For one input, there's one output. Okay, so don't say passive vertical line. What'd I do?
It's miles ran.
Ran. Miles ran.
Why?
There we go.
Miles run would be past tense.
Miles ran is past tense.
Miles run is fine.
Okay.
So we got that. So there's one output. Okay, so sometimes that's hard to kind of verbalize. One input, one output. One input, one output. That's a function. Find the domain. All right, first of all, let's explain, is it discrete or continuous? Okay, is it discrete or continuous? Can you run a fraction of an hour? Can you stop after 2 hours and 15 minutes? Can you stop after 2 hours and 20 minutes? Okay, so what does that tell us?
Continuous.
It's continuous. All right, so it's continuous. What do you think? Now, how can I label the domain? So now you don't list individual points. You can't say 0, 1, 2, 3 because we have to include everything. Now, does it give us a end time? So theoretically, does it say there's a maximum that we can run? No, I might be I had an uncle who ran ultra marathons. He would run 100 miles at a time. He was psycho. Okay. Yeah, so like that takes a long time. So how do you think we could label the domain? What do you think we're going to answer? How can we list all those numbers? We're at an impasse here. All right, tell me if this makes sense. I'll give you x is less than 0. Does that make sense? So can we run negative hours? No, can't run negative hours. So if that doesn't make sense, what could make sense? Mason.
X is greater than 0.
Oh, Mason, that's worthy. That's worthy of a twig. Okay, x is greater than 0. Oh, I'm out of candy, so you guys can quit asking questions. X is greater than 0. Now, theoretically, you couldn't run infinite, but we don't have an end time. So it's going to be x is greater than 0. That's going to be my domain. We want to graph it. So we want to come up with some points. Let's list some points that are greater than 0. So I'm going to do an x, y, and I got y equals 5x. And just to give a starting point, I'm just going to plug in 0 because if you run 0 hours, you're going to run 0 miles, okay? Just to kind of have a starting point. And you don't have to plug in everything. Just plug in nice numbers. So just plug in 1, 2, 3, and 4. That's fine. 1, 2, 3, and 4. So that gives us an idea where we're headed. Theoretically, we could plug in anything, but we want to make things nice. All right, what's 5 times 1? 5. 5 times 2. And then we get 15 and 20. Now we want to make this a graph that's readable. Okay, when it's drawn like this is automatically 0, 0. Okay, that's starting at 0. Okay, the way it's drawn. Like again, don't make this 1, 2, 3, 4, the first 4. Spread it out. We want to use a little bit of the vertical. We don't want to, cram it all in. So I wouldn't go by tens, and even 5s, I'd like spread it out a little bit more than that. And you can, for this, it wouldn't hurt. You can go to that second line and make it a 5, and then the fourth line a 10, and then 15, and then 20. That technically makes it 2.5, but we don't have the half ones at this point, so that would be fine. Plot those points. You still need to plot the points. 1, 5, 2, 10, 3, 15, 4, 20. And what we'll do, since it is continuous, you connect it. You do need to put an arrow because we can run more than 4 hours. I can't run anything below 0 hours, so I don't need to put an arrow there. But that's going to keep going. Okay, for that. So we're going to plot those, draw that line through there. All right, good. So I could estimate. So I could plug in like 2.5, but I could also go here to 2.5 hours. I could go up here and figure out where that's at as well. So I can use that. All right, let's take a look at this next one. I think this one's okay. All right, good. All right, I like part A. Now tomorrow we're doing this quarterly checkpoint. We're just seeing what you got. There's nothing to study for. Nothing to study for. So just look, just come ready to go and just do your best on it. But this is an example of something you might see. The linear function y equals 145 plus 30x represents the cost of an airline ticket after adding x checked bags. At most, 5 bags can be checked. Interpret the terms in the coefficient. What's that mean? What's that mean? How many terms are in this equation? If you look at that, there's how many terms? 2. Okay. Which one is the coefficient? Let's see if we even know that. Okay. As you look at those.
The 30?
30. Coefficient is whatever's with the variable. So the 30 is with the variable. So let's look at that. So the coefficient is 30. What does that represent in this situation? The number of gallons of fuel on that plane?
Yeah.
Okay. The number of passengers on the plane?
What's going to vary with each
Checked
ticket?
bags. Checked bags. You're kind of on the right part. X deals with checked bags. So it has to do with checked bags. Okay? Ava.
Cost of each check bag?
Cost of each checked bag. Each bag, that means each bag you check will cost you $30 extra. So that is the cost of each checked bag. What's the 145 represent? What's the 145 represent? Okay, what do you got back there, Jeff?
Would it be the, like just your normal ticket price?
Normal ticket price, cost of the ticket. Good, cost of the ticket. Now, I don't fly a ton, maybe once every 3 or 4 years. I don't know, not a lot, but before bags were free.
Yeah, it's a joke.
Now they charge you, if you're flying, you got a family of 5 and you each check a bag, you're adding a ton of cost to your flight. Okay, so it does cost, so a lot of times they'll say, hey, you got to put everything in a backpack so you don't have to check a bag. But this is how they would do it. Find the domain. Is the domain discrete or continuous? All right, what do you think? Discrete or continuous? Just thinking through this one here. Let's go back here, Jeff.
Discrete.
Good, because you can't check a partial bag. So it's discrete. Can't check a partial bag. Now, what is the domain? So that means we're going to list individual values. Now here it does make sense to include 0, because can you check 0 bags? Absolutely. Okay, absolutely. But what's the most we can check? Ava?
5.
5. So it would be 0, 1, 2, 3, 4, 5. Okay, you can't let you check anymore, or the plane will be too heavy. Graph the function. All right, give me an XY chart. XY. Plugging in 0, 1, 2, 3, 4, 5. My equation is y equals, what was it? 145 plus 30x. So I'll do the first one for you. If I plug in 0, your ticket price is just 145. All right, plug in 1, plug in 2. Make a table. Make a table. Yep. Oh, make sure you have this. Don't make me head up there. It might be a little low, small. All right. Starting with 0, then plug in 1, plug in 2, plug in 3, plug in 4, plug in 5. Okay, for that. And we can plug in all of them.
Because if you check 2 bags, that's $60. I gotta go into 125. Right?
And now once you get that in, think your scale. Don't maybe not put anything down yet, but think what a scale we could have. We got some big numbers here.
bags, you have to pay for it first. Okay, so how do we?
How much is each bag?
Yeah, do that. Alright. Stuff like that. Alright, so you, yeah, we'll get into that equation. It's not 290. That's just that. Okay, where does the X go? 30, you do 145 plus 30 times. Okay.
Because, no, 145 is each bag is $30. So you're gonna go 45 plus 30 times one. For the first time. Okay. What would that be?
Yeah, alright, what you got? Yeah, alright.
Okay, 45, I get 145 plus.
Okay, third one, alright, we got a tough one. Because we split the two in the wrong spot. This is our equation right here. 145 plus 30 x. Our x goes there, you don't take 145 times 2. That's gonna be the cost of the bag. It'll be 145 plus 30 times 2. Okay. And we just take it from scale. Alright, alright, that's not gonna be 0 because that would be the number of bags checked. Okay, you still, no, it'd be 30 times 0, which that's 0, but you have to add it to 140.
Guys, each time you check a bag, what's the price going to go up by? Isn't it $30? Right?
No, so that one's gonna be 145.
And if you put in your calculator, 145, everybody do this, 145 plus 30 times 1. Okay, so what's that cost for one bag? What's one bag? What's that?
175.
175. How about 2 bags? Mai, what'd you get for 2 bags? The table should be done by now. Okay, so we're going to go 145 plus 30 times 2. 205. Now, guys, from this point on, couldn't you just add 30 to your answer, right? You don't have to plug that in every time. It's going up 30 each time. So what would 3 bags cost? 235. How about 4 bags? And then 5 bags, which is your limit? 295. Okay, good.
Yeah, I had a lot of them.
Good.
Good thing. All right, so hey, make sure you get that fixed. Make sure you get that fixed. That's the number of bags checked. You still have a price of 145. That doesn't change. For here, now we got to graph it. Go ahead.
Go ahead.
No, you're on.
Okay, guys, spread out. That makes sense. Spread this out. So let's skip every one here. So we're not all jammed in there. And again, we go up to 5. Okay. Now we're going up to 295, right? So what do we want to make each line? What do you think?
50.
50? Yeah. That's pretty good. That's a lot. You want to try 50? Everybody agree? Maybe 50 every other one?
50.
Yeah. So 50 Hondo, 150, 250, 3. Okay. So what was the first one? 145. Oh, we got to do, if you check 0 bags, your base tickets, I'm sorry. What would your base ticket if we checked 0? It'd be 145. So right here. Okay. Almost 150 there, right? Then what about the first bag? Is what?
175.
175. So here's what? Here's 150. This would be 175 would be about what's halfway between 175 be right here. Okay. What's the next one? 2 bags would be what? So 205, just a little above 2. What would 3 bags, guys? 235. So this would be 225. 235, just a little bit above that. And then what would 265? 265 would be, here's 50, 75, 265 be about right in there. And then 295 would be your 5th bag, almost 300, about right in there. Now, am I going to draw a line here, guys? No, it's discrete, right? Because you can't check partial bags. Okay? Partial bags. There we go. And it should make sense. It should, even though we didn't connect it, it should climb in a linear fashion, even though it's discrete. You kind of see it there building up. How'd you guys do on that?
I think once they got there, they're okay. It was the getting that table. So let's look at that last one real quick, especially the interpret part. Let's see. Linear function m equals 10 minus 144p represents the amount m in dollars that you have after printing p photographs. All right, interpret the terms in the coefficient. So the 144 and the 10. I want you to think, what do those represent? The 144 and the 10. All right, take a second. Think through that.
Oh, hey.
Jenna Reynolds, any idea?
Would 10 be the domain?
Okay, but what does it mean in the context of the problem? So like
Oh,
X,
1.44 would be the coefficient.
it is the coefficient, but what does that have to do with photographs and the situation? Let me go with Austin first.
10 is the amount of photos printed.
I'm going to disagree. What is the amount of photos? This is right here. The amount of photos is represented by P, and we don't know what it is. Ava?
10 is how much you have to spend, and 144 is the cost to print each photograph.
Yes, 144 is the cost of each photo because we're subtracting that away. So that is going to be the cost of each photo. Now, 10 is the amount of money you have to start with. Okay, that's what you got in your pocket, I guess. So that's the amount of money you have to spend on photographs. But we'll just say the amount of money to spend. Can I get a partial photograph? No, so does this make this discrete or continuous? Discrete. So this will be discrete. Now, what is our domain? I'll say discrete because you cannot purchase a partial photograph. All right, now our domain. It doesn't tell us directly, but we are limited. We are limited. You could get, and we're going to include 0. You could get 0 photographs. But is this going to go up forever? And what is limiting us? What do you got, Ryan? The 10. The 10. We only got $10, right? We only got $10. So think about this. What does one photograph cost? 144. So I got to get my calculator out. That never works. Oh, there it is.
It's slow there.
I know. Okay, so if we buy one photograph, how much money do I have left? 10 minus, and actually, we're gonna have what left? 856. And here, let's do this at the same time. We're gonna make our table at the same time we do this. Okay, so right underneath where you got domain, put X, put Y. X is the number of photographs, and if we put 0 photographs, you're gonna have $10 left. If you get one photograph, what's gonna be left then? According to our calculator?
856.
856. So if I buy one photograph, I got 856 left. What do I have to do to figure out 2? Just do what? Subtract another what? 144. And what is that? Zach?
It is 7.12.
7.12. So when you're a cashier, I hope you say $7.12. Give me 7.12.
There's your change, 7.12, sir.
Okay, so keep going until we get to where? Okay, until we get below 0. Okay, keep going. Subtract 144 till you get below 0. So I'm going to subtract another. So 144, I got 7.112 minus 144, 568. I'm going to run out of room. If I get 4, what is that? It gives me 424. We're getting closer. How about 5? That's going to give me 280. Is that right? How about 6? 6 will give me 136. What about 7? Negative 0.04? Or 0.08? I think because we're subtracting 44. 0.08. So what's the most number of photographs I can get? 6. So what's my domain? 0 to what? 0 to 6. All right, I'm going to leave that graph because of time, and we're going to pass out the homework. But that would be the case here, so don't worry about that graph. This includes what we did as well from Tuesday. You might need to look at your notes. Okay, the back is what we did today. The front is what we did yesterday and Tuesday. I'll give you one. You want to get some free copy of it, Mr. Clark? Yeah. All right, well, yeah.